Okay, welcome. In this video, I'm just going to introduce you to what a local extreme values are, so a local minimum and a local maximum. So suppose C is in the domain of F, and suppose that X is in some open interval containing C. And actually, I'm going to label a couple of C's. So let's say C1 and C2. So suppose C1 and C2. So suppose C1 and C2 are in the domain of F, and X exists in some interval containing these C's. Okay, so let's just sketch one out visually. So how about I say C1 is right there? And I'm going to draw this point here. So here is the ordered pair C1, comma, F of C1. I can also write this out. Here is F of C1. So if F of C1, we have here this F evaluated at C1 is smaller than or equal to the rest of F of X, and F of X is here, Y equals F of X, when X is near C, and so, here's a little neighborhood around C, and I should be specific, C1, then C is a local minimum. Now let's go ahead and do the same thing, and I'm going to pick any spot. I'm going to say this is C2 here. So here I have F evaluated at C2, and go ahead and write these subscripts of 2 here. So if F evaluated at C2 is larger than the other values of F of X in some neighborhood again, and here's our neighborhood, then C2 is also a local minimum. And I should be careful when I say neighborhood because that does have a very specific mathematical meaning. So I'm going to erase those little highlights. I'm going to stick with this definition here, which is when our function, when x is really close to that c, that's when we get the local min or max. So as you can see here for a, this is also a local min. Since when x is really close to a, like right here, all these values of f are larger than a. Similarly, B is also a local min for that reason. And then we have another local maximum here. And I'm only talking about local, so I'm not going to use absolute, even though there are some of these here. And we're just sticking to local. Hopefully this definition helps you see that you can have local mins and maxes as long as you're really close to that low point or high point.